welcome to Tuesday's edition of Cracking the Cryptic, where I think I already know the title of this video if I manage to solve this puzzle. This needs to be called the ultimate miracle Sudoku because, well, look at this grid. I get no digits, in fact no digits outside the grid either, and just a few sort of mocking question marks. And I have read the rules once through, and these question marks, let's just say they don't seem to me to be doing a great deal. This puzzle is called, well, it's called X Sums and Sandwiches, which gives you a clue as to what these question marks are. And it's by Emre Kalotoglu. Now, Emre's puzzles of late have been absolutely first class. I think this has a 100% perfect rating on Logic Masters Germany. So I will give it a go. In just a moment. I need to say firstly a very, very happy birthday to Stuart Marsden. Stuart, it's your 40th birthday, I think, today. Your friend Lucy Stewart let us in on that secret. I hope you have a very, very happy day indeed, with, of course, plenty of cake. Now, the screams outside remind me, I should warn you, today we have some guests round, so it is possible this video will get interrupted. I hope not, but it is possible. And it's possible there'll be more noise going on around me than might otherwise be the case in normal videos. Other than that, what to mention? Well, if you own any of our apps, you may have noticed, for example, if you own Thermo Sudoku, the app just got a massive update. I think it was only yesterday, so all 100 puzzles are now out, all with hints. And yeah, do check out the apps if you're not aware of them. They are, well, they're our pride and joy in a way, because each app contains 100 handcrafted puzzles that have, you know, they really are unusual in the world of Sudoku apps. And what we're doing at the moment is we're going through each of the apps, making sure they've got the 100 puzzles in there. And that's all happening very imminently because we're hoping to release a new app in just a couple of weeks' time. So watch this space and I'll have more news on that in due course. So that said and done, let's get on with X Sums and Sandwiches, and I will read you this extraordinary rule set. So normal Sudoku rules apply. Clues outside the grid represent any positive integers, and they show the sum of the first X digits from that direction, where X is the first digit. So in other words, they are valid X sum clues. I'll explain what that means in just a second. They also show the sum of the digits sandwiched between the 1 and the 9 in that row and column. So these are doing, although we don't know what they are, and that seems to me to be problematic, we know that they represent both the X sum. Let's just work out what an X sum is. So let's imagine this square was a 4. That would be saying that this question mark, were we given it, would be telling us the sum of the first 4 cells in this direction going down the grid, because that's from the side that the clue is. Let's imagine this was an 8 instead, then it would be telling us the sum of the first 8 cells. So that's how X sums work. Now, how do sandwich Sudoku clues work? Well, they work by telling us, let's put a 9 and a 1 in this column. So the question mark would be representing the digits sandwiched between the 1 and the 9 in the column. So all we're being told is that the X sum for this column and the sandwich for this column are the same number. And that is it, which is absolutely ridiculous. Do have a go. The way to play is to click the link under the video as usual. Now I get to play Let's Get Cracking. And I have not got a clue how to do this. I'm guessing that... What am I going to guess first? Let's talk about sandwich Sudoku first. Maybe we can establish some boundaries, certainly on the upper end. Because if you put the 1 and the 9 in the extreme positions in a row, then because of the secret, now the secret is something I only tell my very favourite people, but if you're watching this video, you're definitely one of my very favourite people. And the secret is that any complete row of a Sudoku, because it contains the digits 1 to 9 once each, sums to 45. The same is true obviously for a complete column or a complete box. But that means that the maximum sandwich clue you could ever have would be equal to 45 minus 1 minus 9, which is 35. So the upper boundary for every question mark clue is 35. Now the lower boundary, I think, is it's 2. So there is a lot of leeway here. What you can't do is put a 1 in a thingy thing clue, in a sandwich clue, because if you do, you're implying that there is a sum of 1 between the 1 and the 9, and that will necessitate repeating the 1. So from a sandwich perspective, we can say at the start that every question mark clue is some number between 2 and 35 inclusive. But 2 is an invalid X sums clue, isn't it? And that's because how would you ever construct an X sums clue that was 2? Let's look at this row and try and make this question mark equal to 2 from an X sum perspective. That would be saying we look at the first digit, let's say we make that a 1. Well, that's saying sum the first cell. Well, that's just 1. Now, if we make this 2, on the other hand, that's saying sum the first 2 cells. And we're going to have to put something that's not 0 in here. And that's going to push the X sum above 2. So actually, we have now reduced the possibilities from 2 to 35 to 3 to 35. But 3 is possible because that would be a valid X sum clue. In fact, 3 would also be a valid if you did that. Isn't that a correct form of clue? You'd have 2 here, so the X sum would be 3, 2 plus 1, and the sandwich would be 3, with a 3 between the 1 and the 9. So 3 is absolutely possible. Right. So my next thought is, do we know, I'm looking at one, I was going to say one across, I've just done a crossword, that's probably why. But what I mean is the first row of the grid. Because I'm noticing I've got, well, I was going to say I've got question marks on both sides. Now that's obviously true, but those question marks actually have to be the same number. And they have to be the same number, not because of their X sum property, but because of the sandwich property. Because whatever is summed between the 1 and the 9 in this row is definitely is the same number from the left or the right side, isn't it? It's those 3 digits. So the question mark clues in row 1 are the same number. Okay. In fact, I've just noticed something else about row 1. Okay. This is probably where you're meant to break into the puzzle. It's only taken me 10 minutes. But yes. Okay. What I didn't say before, and hopefully it goes without saying, is how could you put a 9 in a question mark clue? And you can't. And this is not because of sandwich rules, but it's because of X sum rules. Because the implication of a 9 in a question mark clue is you sum the entire column for the X sum. But the sum of the entire column, because of the secret, is 45. And we know 45 is greater than 35, which is the maximum sandwich clue. So you cannot start with a 9. So look at row 1 and ask where the sandwich clues go. Where do we put the 1 and the 9, the sandwich crusts? And the answer is you can never put them adjacent to a question mark. Because to do that would imply you're either breaking the sandwich, if you put the 1 there, or you're breaking the X sum and the sandwich, sort of, as a result, if you put the 9 there. So the only places for the 1s and the 9s in row 1 are these 3 cells. Now, can this therefore ever be a 1 or a 9? Well, if it is, the 9 will be adjacent, and from a sandwich perspective, this clue would be a 0, which won't work, because you can't have a 0 X sum clue, because you will not put 0 in this cell. So that means that's not 1 or 9, and that means we have a start. That is the position of the 1 and the 9 in row 1. That's already absolutely beautiful to me. That a clue without any, well, a puzzle without any clues, really. You know, it can give you something like this. So this is a single digit. I guess that's not that surprising, given that the x sum has to work from both sides. Although, yeah, this is good. This is good. What is the length of the x sum? Oh, this is really... Oh, hang on. Oh, have I broken this? No, maybe not. No, maybe not. I think it's still a good thought, which is, what is the length? This digit here, I don't know what it is. Let's just put 7 in. It might actually be 7, I think. But if it's 7, why is that? How do we make that total from a valid x sum from both sides? Remember here that what we can't, because the first digits in these two positions are different digits because they're in the same row, the length of the x sum from both sides is different. So that immediately rules out low digits here, because a digit like 5 we could only make with a 2-cell sum, because if you add up 3 different numbers in a Sudoku, if this was a 3 and you kept those down as low as you could, they'd still be 6, which is definitely bigger than 5. So you need this to be capable of being a 3-digit sum. So you're immediately looking at 6, 7 or 8. And I have a feeling 6 is going to break, isn't it? Because 6 is going to require, well, the 3 would have to be here, because the 3-digit x sum would have to be 3, 2, 1. Well, because it would need to get to the 1. And the only place, if we try it from here, we obviously won't get to a 1 here. So 6 would go 3, 2... Oh, no, this doesn't work. This doesn't work because of the other side now. You can't make 6 in a domino here if you can't use 1, 2 or 3. So that's nonsense. Right, so that's not 6. Sorry. I should have seen that immediately, but didn't. Right, so this... What about 7 then? 7 could be 1, 2, 4. So that can be a 3. Oh, 1, 2, 4 can't be made in... You can't put the 3 in. If it's 1, 2, 4... as the x sum from one side or the other, that requires you to put the 3 in to say sum the first 3 cells to be 1, 2 and 4. There are 3 digits. That doesn't work, so this is 8. So this is... Oh, 8. 8 will work because we can put the 3 first. But we need a 1. We need a 1 in that x sum, so this is the 3. Look, we're going to get this row. 3, 4, 1, 9... And now 2 and 6 from the other side. 2, 6. So we're summing these two. We're summing these 3 from an x sum perspective. 3 plus 4 plus 1 is 8. That's what's in the sandwich. 2 plus 6 is 8. That's what's in the sandwich. These two squares are 5 and 7. And we have a start. Now, what does that mean? So basically, I've done this question mark, and I've done this question mark completely. 6 here, that must be difficult. So 6 is saying sum those from an x sum. Sum those, so it's at least... Okay, here is a small deduction. And I'm sure you can hear the shrieking. It's putting me off. It's putting me off. The only reason my brain is being slow is because I'm being put off by shrieking. Anyway, these 6 digits must sum to at least the triangular number for 6. In other words, 6 plus 5 plus 4 plus 3 plus 2 plus 1. Now that's 21. So this column has a sandwich total that is at least 21. Now, 21 in 20... Oh, this can be 3, can't it? Yeah, okay. Oh, no, it can't, because it can't use the 6. Right, here is an interesting point, I think, which is if we think about how long, how big is the sandwich? You know, is it a Big Mac or is it just a hamburger that we're going to put in column 8? And the answer is that it must be at least 4 cells long. It's quite a big sandwich because these cells sum to at least 21. let's try and put the 1 and the 9 only 3 cells apart and say, how can we make those add to 21? And the answer is we can't do it, because we can't use the 9. The 9 is in one of the crusts, so we'd have to use 876, which would break this cell. So the sandwich length here is 4 cells. Now, so if we make this extreme, these digits would be included. If, on the other hand, we put that digit as a crust, those digits. So these digits here are not 1s and 9s in this column. Now, what does that mean? Actually, that's not actually that helpful, is it? I don't think it is. Because I don't know whether the 1 or the 9 is high or low. I mean, if I could rule this cell out, and at least I would know I had a 1 or a 9 here, and a 1 or a 9 in box 9. Nah, I'm not really... I'm sorry, there's probably something clever we can do here, but I'm not understanding how to do that. One of those is a 7. So one of those is a very big number. Right, yeah, hang on. One of these is a very big number, and that must be important. Because look, if I put 7 in there, now from an x-sum perspective, we're summing all those digits up. And the triangular number for 7 is 28. And that's it. That's beautiful. Right. So this is important. Right. This is where we should have looked next. The triangular number for 7 is 28. So the x-sum is minimum 28, which means the sandwich is minimum 28. But how could we have a bigger sandwich total than 28 in this column, given that 7 is not in the sandwich? So look, if I put 1 here and 9 here, then from a mathematical perspective, the biggest size I can put in this sandwich is 45 minus 9 minus 1 minus 7. And that is 28. So in other words, what we're being told is there is only one digit in this column outside the sandwich, and it is the 7. So yes. Okay, but the other problem is I don't know if this is the column or this is the column. Okay, so if it was this column, then this would have to be... Oh, yeah, this would have to be the 1, this would have to be the 9. Also, this would have to be an 8. Because don't forget, from an x-sum perspective, we're saying the first 7 cells sum up to 28. In other words, they are 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. So this is one possibility, 7, 1, 8, 9. If this is the 7, we go 1, 8, 9. So the problem is we don't know which of these is accurate. So there's a 1, 8, 9. We can get rid of the orange there. So, my hunch is that this one is where the 7 lives. And the only reason for that is that it makes use of the 9 and allows me to place a whole load of digits, which I don't think I can do if this one is the 7. Oh yeah, because yeah, in fact, if this one is the 7, that's the point, isn't it? That can be 9. Whoa, 9. That can be... Oh, no, hang on. No, it can't be, because that's going to affect the x-sum. Oh, that's weird. That's weird. Okay, no, it can't be. So the fact that there is a 9 here is actually irrelevant. Sorry, I wasn't understanding that. I was thinking it was important, but it's not. Because if this is a 7, and I do try and put the 9 here, that's affecting the x-sum and making it bigger than 28, which it cannot be. So the 8 and the 9 have to be at the bottom of one of these columns. Okay. Okay, but we still don't know which one. So in fact, that equalizes the odds in the sense that I was going to bet this was the 7, but now I don't think I have any clue at all. Which is disappointing. Okay. And the other digit will be a 5, which is going to sum 5 cells. So it's the triangle number for 5 is 15, so we're looking at least a 15 sandwich. But 15 sandwiches, I think they grow on trees, so to speak. 4 over here. I don't see how we use that. What am I missing here? What am I missing here? How do I Is it the 6? Maybe it's the 6. Having thought about where the 7 goes, maybe I can think about where the 6 goes. Or what happens to the 6 as a result. So the 6 now is summing those 6 cells. How is that affected if this is a 7 and this is a 1 and this is an 8 and this is a 9? Is it affected at all? I guess if that's a 9, there's one thing I can see there. In fact, there's 2 things I can see there. I'm not sure if this matters or not, but look at this column now. And let's consider what must be included in this sum. Now, if there's an 8 and a 9 here, because 8 and 9 can't go in those 3 cells, they must go into the X sum clue. So that means that the minimum value of this is not 21 anymore, it's much bigger. Because it must include the 8 and the 9. So let's just put the 8 and the 9 in up here, just to try and do some calculation. And we can put 1, 2 and 3 in there. So the minimum sum here is now 29. Or what did I say before? 20. Ooh. That's really annoying. Oh no, it's fine. It's fine. It doesn't work. I was about to get very cross because I was thinking this could work. But it can't. And here is why. It's very clever, this. Good grief. Right. So this is the very minimum I can now make the X sum if I have an 8, 9 here. Now that adds up to 29. Now 29 would then be the sandwich total, minimum. But the problem with the 29 sandwich total is that has 6 outside the sandwich, because we know that the 1 and the 9 will define the sandwich in this column, and 45 minus 1 and 9 is 35, and then 6 here must be outside the sandwich to get down to 29. In other words, this would be the only digit in this column outside the sandwich if the 8 and the 9 are here. So the 8 and 9 must be in the X sum. But the problem with this is that requires both the 1 and the 9 to be in these 6 cells. Whereas we've just said that the only way this works is if the 1 and the 9 are as far apart as possible. So there is only one, this is the only outie cell. So the only way of getting the 1 and the 9 far enough apart would be to do this, which removes 1 from the X sum and replaces it with at best a 4. It couldn't be lower than 4, could it? Because we've already put the 2 and the 3 in. And now we've broken the puzzle, because this will not work mathematically. Here we've got 18 and 14 is 32 as our sandwich. So that implies these cells need to sum to 32. Well, 32 plus 1 plus 9 is 42, plus 6 is 48, and 48 is more than 45. So we've somehow magicked column 8 to have more digits in it than it can possibly have. So this doesn't work. I like that. So this is not 8, 9 down at the bottom here. That must be the 8, 9. Therefore, this is the 7, this is the 1, this is the 5. And we can do all of that in a jiffy. Now there's a 1 up here, look. There's a 9 over here. And we get to have another think to ourselves. And the think we need to have this time is going to be about... I do not know. I really want to pencil out these just to feel like I'm making progress. I'm going to do it. 2, 3, 4, 5, 6. There we go. That's the desperate stakes we're in with the ultimate miracle. Okay. So now I'm wondering, lonely as a cloud. I don't really know what to do now, because all the pressure's come off my 6 clue by the fact that I don't have this 8, 9 trickery going on. We know that this is at least 21. Wow, I haven't got a clue how to do this. What? It's not this 5, is it? I think the 5, I don't think it can be the 5, because the 5 is naturally under less pressure than the 6. So it must be the 6 we have to think about first. Otherwise the world would not make sense. Perhaps what we've got to do is to decide whether there could possibly be a 9. So what I'm wondering about is we got into trouble before when we tried to put the 9 in the 6 clue. So maybe that's what we've got to consider. We know that 21, yeah, let's not forget we know 21 is a 4-cell sandwich. Yes, okay, that's what I'm going to consider. Where does 9 go in this column? It's clearly not here. Now 9 could go here or here. No, 9 can't go there, can it? Because we know that the sandwich is at least 21, and we know that's at least 4 cells, because this 6 has to not be in the sandwich and the 9 is not in the sandwich. So 1, 2, 3, 4 would put the 1 here, which doesn't work because there's already a 1 in that row. So the 9 could be here. Or the 9 is higher in the column than the 1. So the 9 could be in one of those 3 cells. But at least that's interesting. And the reason I say that's interesting is that what we're doing there is we are putting pressure on this. And the reason we're putting pressure on this is that we're including the 9 in the sandwich, in the X sum, and we're forcing the 1 out of it, because whichever one of these was the 9, the 4-cell sandwich that must at least emanate from the 9 is going to place the 1 down there and outside the X sum. So the question I want to ask, I think, is it possible for there to be a 9 up here and no 1? So the best we could do would be 9, and then we could put 2, 3, 4, 5. That's the absolute minimum we could put in. Now that's 14, 29. I don't believe it. I don't believe it. Why don't I believe that? Well, that's because it works, doesn't it? That's so annoying. That's so annoying. 29 is perfect. Maybe this is right then. Maybe this is right. What is causing this to fail? So what I'm thinking here is I can put the 1 here. The X sum is now summing to 29, which means the sandwich has to sum to 29. 29 plus 10 is 39 plus 6 is 45, and that might be correct. So perhaps I've got to do it the other way round then. Perhaps the actual trick is to prove this can't be a 9. But that's surely easier for this to be a 9 and that to be the 1. Is that not right? Or am I going mad? Sorry, let me just think about this for a second or two, just to see if I can understand why there's a problem. Because what I think I'm feeling is that if this is... Does it have to be that one, or could it be that one? I'm not even sure which of these needs to be the 9. I think maybe all of them could be. The 1 would get pushed down here, and the 1 can go in any of those cells. That's the 1. If that's the 1, that would be the 9 in the column. These 4 cells would have to sum up to... But then they only have to sum to 21, and we know that's totally possible. I'm getting confused here. I don't see how to do this at all. Maybe... Well, maybe what I've got to do is to think about the cells that overlap. That's a thought I've not had. Right, okay, that might make sense. So what I'm thinking is, if that's the 1, yeah. So, okay, let's change tack. I've been thinking about 9s, but maybe the correct thought was to think about 1s. And that's because in this box, the only possible position for 1 that's in this x sum is here. And in fact, the 1 could never be lower down this column than here, because if it was, if we tried to put the 1 here, for example, we know the sandwich is at least 4 cells, and that puts the 9 there, which doesn't work. So let's try and work out whether this can be a 1. And the reason I think this might be interesting is that if this is the 1, we know this has to be the 9. We know that those 4 cells form the sandwich, and these 6 cells form the x sum. Now, obviously, these 3 cells are in both the sandwich and the x sum, therefore. So they can be, in effect, be removed. And what we're left with is that this cell needs to be the sum of those 3 cells in order for the maths to work. And that is not possible. QED. That's ridiculous. That is not possible. And the reason it's not possible is, what are we going to put in there? Because we can't put 1 or 2 in, so the best we put in is 3. 6 plus 3 plus 1 is 10. I cannot put 10 into a Sudoku cell, and anything else I put in there is going to make this bigger. So this is wrong. Wow, 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 wow. Good grief. That's not easy to see. So that is not 1. Now, if this is not 1, the 1 cannot be here. Because if the 1 is here, here, or here, I'm convinced that the 4-cell sandwich is then impossible. There are not 4 cells. There's 4 cells here, but only into a 6, which is not a 9. That doesn't work. This doesn't work. So the 1 is low and the 9 is high, and that is not a 9. So the 1 is down here. Now that's important, of course, because that's telling us that 1 is not in the x sum. 9 is in the x sum. So now we can reverse back into the logic I was doing before, which tells us that the best we can put in here is a 2, 3, 4, 5, 9, 6 sextuplet, which added up to 29, and that's the only thing it can be. Because if we make it add up to any more than that, the outside 6, the 6 that's outside the sandwich, breaks the puzzle. So we need to have a 9 here. We need to have a 1 here. We need to... we need these 6 cells to be, therefore, as minimum as we can, given we can't put 1 in. So they are 2, 3, 4, 5. Oh, this is so brilliant. Now look, this is a 7, 8 pair. There's an 8 here, so we get another digit. Every digit is like hard won and beautiful, but I'll take anything we can get. So we've got, now we've got an 8 down here. I bet you can't put 8 as a Can you really have 8 as a valid X sum? No. No, you can't. Because if that was an 8, that would be saying sum those 8 cells up. Now there's a 3, therefore, in the column that's not in the sum. So these cells would add up to 42, because 45 for the whole column. And 42 is not a valid sandwich total, so that is not an 8. So the 8 is in one of those two. Now, okay, we can get rid of the green highlighting there. I think we can get rid of the orange highlighting because frankly we've used this clue up now. There's nothing more I can learn from this clue. So now I've used this clue, this clue, this clue, and this clue. So maybe the 5 clue now? Just because we know a little bit more about 1s and 9s. Okay, let's have a think about this. So that from an X sum perspective, we're summing these up. But that's okay. This cell is not a 1 or a 9 now because it sees both. So is it this question again about eight and 7 here? You can't put a 1 in any of those. So 1 is almost being forced into the X sum here. – 15 is the minimum X sum, so 15 is the minimum sandwich. No, that's not right, is it? Because the 8 and the 7 here are problematic. Because in this column, you can't put 8 and 7 in those cells. At least one of them is going to be forced into the orange cells. So that means that the minimum sandwich here is going to be a 7. We could put the 8 here, so we could leave the 8 out, but we've got to put the 7 in if we leave the 8 out. So we could do 1, 2, 3, is that? 5, 7? I think that's probably right. That might not be, but it's something like that, I think, as an absolute minimum for the sandwich. No, not the sandwich, the X sum. So now that is 18. So 18 is the minimum. Okay, well that's an improvement on 15 for a very tiny reason, which is that 15 can be made as a 2-cell sandwich with indeed with 8 and 7 in it. But 18 can't be. So we now know that this column has at least a 3-cell sandwich in it. Oh, where's my 5 gone? Let's put that back. It's got at least a 3-cell sandwich. Wow, okay. So how do I use that to my advantage? I don't know. Maybe I can force the 9 down this column. Is that a sensible idea? Because the 9s can't be in these 2 cells. Now, if the 9 was here, oh, it can, well, can it? No, I'm not sure it can be. Let's check that. If the 9's here, it doesn't work. The 9 can't be here, because if the 9 is here, this would have to be the 1, and that won't work because there's already a 1 there. Oh no, sorry, that's why the 9 can't go there either. If the 9's there, it's going to bump into this 1. So although you can put the 1 here, it will repeat in the box right. So 9 definitely is not in any of those cells. Okay, so 9 in this column is in one of those 3 cells. Now, this is impossible because we know it's a 3-cell sandwich and that couldn't be the 1. So that's not possible. So then I've got the 9 down to one of 2 places now. Okay. So now maybe we do overlaps again, do we? So if that's the 9, let me just check this. If this is the 9, this would have to be the 1. These 3 cells would be the sandwich. These 2 are common. So this digit would need to be the sum of those 3 cells, which would be 9. That doesn't work. Wow. Wow. Okay. This is a good thought. So let's just go through that logic and check it's solid. If this is 9, we know that we need a 3-cell sandwich. So the 1 is forced up to here. It can't be here because of the 1 there. So it's got to be here. Therefore, those 3 cells, because of the rules of the puzzle, the sandwich must equal the x sum. These 2 are in common. So in other words, this digit is the same as the sum of those 3 cells, and this cannot be less than 3. So this adds up to 9 minimum, and you can't put 9 there if you just put 9 here. So that logic is solid, and that means that this is not 9. And that is a hard-won deduction, but this is the 9. Okay, so 9 is over there. We know 9 can't be in the first position because that would create a massive x sum which would break the sandwich. We're slowly learning, or I'm slowly learning. So now we've got to think about 9 here. So does that mean this is the 1, or is it now possible somehow that this is the 1 and it's those 3 cells? That's what I'm thinking. How do we do that? So if this is the 1, we're saying that those cells then, we're saying these 2 cells sum to these 3 cells. Well, that strikes me as very possible. I mean, that could be a big number. If that's like a... let's make that a 7. I'm just trying to see if I can see a way of making that work. I'm not actually doing very well at that. Okay, but maybe this is worth checking then. Okay, so I'm going to try and make this work. So I've got to make this domino sum to those 3 cells. Now, how do we do that? Because I've noticed that if this is 8, these would add up to 14. And you can't make that add up to 14, that domino, because 9 and 8 wouldn't be available. If it's 7, I also don't think that works, bizarrely enough. Because if this is 7, this is now 13, and I can't make that domino add up to 13 because 4, 9, 5, 8 and 6, 7 is not available. So that could be, it can't be 6, or, oh, it can't be 6 or 5 actually. So it has to be 4 or 3. Oh, come on, break you, what rotten thing. 4 means these 2 cells have to sum up to 10 without using 1, 9 or 4, 6. So they could be 2, 8 or 3, 7. That doesn't, well, it isn't so obvious to me how that breaks. What about 3? If this is 3, this is 9. It can't be 1, 8, 3, 6, 4, 5. This would have to be 2, 7, which it could perhaps be. Bobbins, bobbins, bobbins. Right, okay. So that I cannot disprove, unfortunately. So I can't disprove the one here. Can I disprove the one there? That's the alternative. Let's check that instead. That would be the overlap. And now we're looking at a situation where these 2 cells have to sum up to those 4 cells. Is there any restriction on those that is problematic or not? Not sure it's quite enough. That cell can't be 2 or 5. Then that's solid. That's a solid deduction, isn't it? Because that 5 and 2 are fixed. This cell is always 3 or 4. That is a little bit interesting for this domino, which can't now be a 3-4 pair. So then, right, so if we are in this paradigm, what we're learning is that this domino would be a, that's really massive actually, that's pushing this up very high. Okay, this might be good, because if this can't be 3-4, what's the minimum I can put in here? I could put 3 in here, that's fine. But this digit is now really high, because this is now made of 4. So this has to be at least a 7. So the best I do is a 3-7 pair, I want to say. And that means that those cells add up to 16 minimum. And I can't make 16 in a domino because the 9 isn't available. Right. This is huge. This is huge. Well, when I say huge, I mean modestly interesting. Because it means that that is not the one. And we know we need a 3-cell sandwich in this column, so that is the one. So that is not a 1. And there is a 1 over here. And we are looking at one of those iterations that we were looking at before, where we had a, how did it work? We had those 5 as the x sum, these 4 as the sandwich. Those are overlapping, so these 2 need to add to these 3. But we worked out this couldn't be a high digit, didn't we? It couldn't be 8 or 7 because we couldn't make that work. So this needs to be 3 or 4. Ah, and that was 3 or 4 because of the 2-5 thing. So there's a 3-4 pair. There's a 7-8 pair over here. So there's a 7 and an 8 in these cells. And now, okay, so now this domino is adding up to either 10 or 9. So if it's 10, this is a 4. So we're looking at, oh, I see. So we look at 7 or 8 here and 2 or 3 here. But if this is 3, these are adding up to 9, and only 2-7 is left available. So we'd have to have the 7 can't go here. So, oh, so that's okay. That's interesting. I don't have to improve my options. This is still 7 or 8, and this is still 2 or 3. But if this is 9, that has to be 7, and that has to be 2, and that's the only way it works. But that's weird, because that's not done anything really. Hang on. 2 must be in one of these 2 cells by SUDOKU. 5 must be in one of those cells by SUDOKU. Okay. Okay, over 45 minutes. I'm not that unhappy. I'm quite pleased I got anything in the grid. So I know this is either 8 or 7. So now, so what do I need to do now? Presumably I've got to make my way over to one of these clues on the left that I've not used yet. And that is a bit daunting, to be honest, because how do we do that with any sort of... I can't tell, at least I can't tell at the moment, at first glance, which of these is weak, which of these is worthy of investigation. This can't be 1 or 9, but we already knew that. So, wow. 9 is in one of those 2 cells. Is that somehow relevant for this clue? Maybe actually, yeah. Okay, so let's ask where 1 goes in this row. because I'm seeing that it can't go here. We know it can't go in the first position. And I actually now know it can't go there, don't I? Because if that's a 1, that's a 9, and this 1 and 9 would require a 0 clue here, which from an x-sum perspective is impossible. So the 1 is not in any of those 3 cells, which means that there is a 1 in one of these, one of those 2 cells by Sudoku, because if we can't put 1s there, or here, they get locked in there, which means 1 is in one of those 2 cells. Oh, this is so nearly very interesting, because now right, now this is not a 1. That is what I'm going to allege. Now, the reason I think this is problematic, I'm probably going to be no, I think this is good logic. Right, if this is 1, we know the 9 can't go here because that will create a 0. So we must put the 9 here. But we now know this digit is a positive number that is not 1. So it's capturing this 9 in its x-sum. So this x-sum is going to be greater than 10, and yet 10 or greater therefore has to be in the sandwich, which won't work. So that is very beautiful, and that tells us that this is the 1. It probably tells us that this... Oh, actually maybe it doesn't. Okay, hang on, let's just... we haven't got a clue at the top of column 4. Emre, you're rotten. Okay, so now I was going to say I didn't think this could be the 9, but I think that might be wrong now, because this 9 is in a very different position in this row now to this one, because this one needn't be captured by an x-sum from this side if this is a 2. Well, we can clearly see, here's something we can clearly see. If this is a 9, this is a 2, because we've got a 1 cell sandwich. And if we had a 3 here, it would include the 9 and be too high. So, if this is 9, this is 2. And that's not a 3, because that would break that cell. Oh, and actually it's not a 4, because that would break that cell. So we're looking at least 2 plus 5 equals 7 here. But we could have... No, we couldn't have 2 plus 6 equals 8, actually, because that would break that. That's weird. Okay, so actually, if this is correct, the only way this works is with a 5 here and a 7 here. Now, why is that wrong? It probably isn't wrong, because it's sort of fitted together like a jigsaw so perfectly that it's very hard to believe that this isn't correct. 2 plus 5 equals 7. 7 is in the sandwich. Everything is fitting together here. This would become a 3. This would become a 4 or a 6. This would become a 4 or a 6. Everything seems to be in order, doesn't it? That's very annoying. Okay, but we do have, therefore, the opportunity to disprove. So this works. 9 here works. Maybe this doesn't work then. Although there's a lot less pressure now, because I've got 2 cells to fill the sandwich, where it didn't have before. So, right. Yeah. So, in fact, I've learnt something. This is always 2. And the reason this is always 2 is that if this is the 9, we know this is a 2. If this is a 9, how could this be anything higher than 2? If it's 3, for example, we're being told that those 3 cells sum to the same as those 2 cells. Well, this is common, so we're saying that cell sums to those 2 cells, which makes it a double-digit number, which is impossible. So this is always 2, whether or not whichever of these is 9. Now, if this is 2 in this iteration, we've got 11 here, so we need these 2 to add to 11, which means they're 4, 7 or 5, 6. And that seems to be possible, doesn't it? Oh, No, actually it's not possible. Well, no, one of them is possible. But if we ask where 7 goes in this row now, it's got to be in that domino, because it can't go there, and it can't go in these cells. So this would be 4, 7. So hang on. I'm not sure how much further this takes us. So what we've now learned is if we go 2, 9, we have to go 4, 7 here. This becomes a 3. And these become 5 and 6. But if this is the 9, we know that's the 7 and that's the 5. And we get 4, 6 in those two positions. So we know there's a 7 in one of those two cells. Maybe I'll highlight that. I don't know that this is the 9 though. That's problematic. The 9 can still go in either of these cells. Which is crazy, isn't it? I mean, that's a lot of work to rule. Ah, no, well, this being a 2 does give me that digit, I suppose. So that I take that. Oh, yes. Ah, right. This is good. This is really amazing. Oh, what an amazing puzzle. I mean, what sort of mind fixes upon this as a possible rule set and believes it would be ever possible to make a grid out of it? Emre, I worry about you, but thank you very much for doing it. So this is a 2. Now we've forced that, so this is now a 3. Now that means we know those were adding up to 10 or 9. Well, they can't add up to 9 anymore because this is a 3, so that must be the 7, which tells us that's a 4, that's a 3. So actually we now know this is a 2, 4, 5 triple apparently. Now do we know more than that? I don't know is the answer. I know there's an 8 up here. So in this column, oh, I know that's the 2 in the column by Sudoku of all things. So now there's a 2 in one of those cells. This square is not a 2 or a 3. Those two squares are a 6, 8 pair, I think. So these squares are now known. They're 1, 3 and 9. So these 3 squares are known. These are 4, 5 and 6. 2, 4, 5, 6, 8. 3 here. Yeah, so this is reiterating what we already knew, which is the 7 is living in a home in one of these two, in one of the green cells. Is there some more Sudoku that we can do as a result of this? I'm not sure that there is. That's not a 3. All of these triples that we've learnt about on the right hand side don't, because we've got so little on the left, they don't seem to do anything. So okay, alright, so now we have to think more about what's going on the left hand side of the grid, presumably. And the question then I'm asking myself is, where on earth do we look next? It's going to be this question again, isn't it, about 1s and 9s in some particular orientation that's going to be problematic. So I've been looking at this clue, so it's not likely to be this clue. I've got a 4 here, which is summing those 4. But I don't think I know. I could put a 1 here. I don't see the reason why I couldn't do that. So I think this could be quite a low total, although it couldn't include a 3. So the minimum total for this would be 1, 4, 2, 5, which is 12, I think. So this is at least a 12 from a sandwich perspective, but 12 can be done very naturally in 2 cells. So So that doesn't seem to be very useful to me. Maybe you can, that can't be a 9, look. So what happens if you put a 9 in this 4 sum? Is that going to be difficult? So if you put a 9 here, this could be 2, this could be 3. So then you'd be looking at least 18 as the X sum, which is a 3-cell total. So that would be pushing the 1 wherever the 9 was. The 9 would be in one of these. So that would be pushing the 3-cell total down to here. So well, this would have to be the 1. That's what we'd be learning then. So if there is a 9 higher than a 1 in column 2, this is the 1 in column 2. And the 9 would be in either this cell or this cell. I'm struggling to see what the problem is with that. That's the issue. Can anyone see what the problem is with that? It almost looks like it could be true, and that's never a good thing, is it? Whereas, okay, let's try it the other way round then. If the 1 is higher than the 9, yeah, okay, so I think what I might be prepared to say is that one of these, either this 9 or this 1, is a truth. Because in this column, or am I prepared to say that? Yeah, I think that must be right. Because these can't be 1s, the highest I could put the 1 in this column would be here. We know it's at least a 2-cell sandwich if 1 is in the X sum, so that would put the 9 in this box, which puts it here exactly. So 1, 9, these two squares would have to add up to at least 12. They would have to be 5, 7 probably. 5, 7 or 6, 7 maybe. And that would work. But, okay. But if we put the 9 instead up here, we're then looking at a 3-cell sandwich, which means the 1 is in this box as well, and therefore has to be here. So one of these is true, but I don't know which one it is. Okay, so maybe we've got to look. I don't know. It's going to be either. I think we have to keep focusing on these 1s and 9s. Maybe let's take a look at column 1. I know that is not a 1 or a 9 because it's next to this clue. I know neither of these are 9s because of the 9. Yeah, because we've got 9s in these two cells. So 9 in this column. Oh yeah, look. This is where we might be have to look. 9 is in one of these three, and the immediate thing that strikes me about that is it knocks out another position for 1 in column 1, because this can't be 1, or it'll be next to the 9 and create a 0 sandwich clue, which is, well, 0 sandwich clue is impossible, but 0x sum clue is not possible. So actually, it's this, isn't it? This is going to be where we have to look. So now, if 1 can't be here, 1 can't be here, 1 is in one of 2 places. Wow, one of 2 places in the column. Now, well, what do I bet? Got it. I've got it. What's that cell? That cell is not a 1 or a 2 or a 3, so it's at least a 4. And the moment this is at least a 4, the X sum for this column is at least 10. Because if I put, in fact it can't be 10, but it doesn't matter. It's clearly at least 10. And once it's at least 10, how could this be the 1? Because the 9 would go there and this would have to be a 10, and it can't be. So this is not the 1 in the column, and the 1, whoopsie, I didn't want to do that. I want to get rid of the yellowness from there, because the yellowness belongs here. This is the 1, and that means we knew one of these was true, so if that one must be true, that's got to be the 9. I'm not going to redo all that logic because I worked so hard to get it. So that oh, although now I'm worried about that being the 9 because now this is the 1, and this is a 4x sum. Yeah, well that's what we proved before, so I'm going to trust what I did before. That must be the 1 because the 1 can't be closer. A 4x sum is at least a 10. So these two cells now are at least absolute minimum a 2,5, aren't they? They could be more than that, but they're at least a 2,5. Well, they're not a 2,5 because that would make this impossible. This is worrying. This is very worrying. So if this is 2,5, I've got 12 as the x sum. So this has to be 12, but it can't be 3, 9, 4, 8, or 5, 7. So it's not 2,5. Ah. Alright, well let's try and prove there's a 2 in there then. If there's no 2 in there, it would be a minimum of 5, 6, which is 11, 12, 16. That would be 7, 9, repeat the 9. Right, so there is a 2 in there. And the question, and we know it's not 2,5, so it's either 2, 6 or 2, 7 or 2, 8. Now, if it's 2, 6, we've got 13, haven't we? So this has to be 13. So it would have to be 5, 8. That would work. At least that works. At least that works. That's good because we didn't have anything that worked before. So if this is 2, 6, this is 5, 8. If this is 2, 7, 9, 10, 14, that has to be 6, 8. Which also, oh, that would give us a 6, 8 pair there. That also seems to work. And if this is 2, 8, we've got 15 when that doesn't work because 2, 8 won't work because this would have to be either 7, 8 or 6, 9, neither of which would be available. So this is not 2, 8, and the 8 in the column is there. It's definitely, oh, whoa. It's definitely in these two cells. So that is not an 8, and this is an 8. And well, that does feel better. I feel better for that, I have to say. Now, do we now... Well, there are a few things I'm wondering, actually. Oh, yeah. Here's something interesting. There's something now, I think, going on between these two cells. Because... how is this going to work? Because I'm noticing this cell sees 1, 2, and 3, so it's at least a 4, and that's affecting this row. It's not a 7. Can it be an 8? Is that just nonsense? If it's an 8... No, it can't be an 8. It's too big. It's too big. No, you can just rule out 8. Forget thinking about question mark clues being 8. Because if they're 8, it's summing that many clues up. And even if that's a 9, it's suggesting the x sum is at least 36. And 36 is impossible from a sandwich, and anything higher than that is impossible. So forget 8 ever going in here. This is 4, 5, or 6. So is that the same? Yes, that's exactly the same. It's apply. Oh no, this one doesn't see 7. Ah. So that could be 7. It'd be quite good if it was 7. That would put a 7 here. 7? Oh, no, I tell you something. It's not 7 for a funny reason. And that's to do with where the 9 goes in the column. Because if this is 7, the 9, even if it's as far away as it can be, only gets to here. And let's think about what the instructions are saying. They're saying add those clues up to get the x sum, and add those clues up, which should be the same number to get the sandwich. And clearly I've added a different number of digits up there. So that won't work. I'm not actually sure that this can be a 6 on that basis either. No, if this is a 6, it's the same problem. The 6 is saying the x sum is saying sum those up. The sandwich is saying sum these up. And again, we've got a problem, and that's on the best case basis, which is that the 9 is as far away as possible. So this is now reduced to 4 or 5. Now let's try that with 5. If this is 5, it's summing these cells up. I can get rid of the yellowness there. But let's repurpose the yellow. So if this is 5, the x sum is summing these digits, which tells us the 9 would have to be high, because if it's here we've got too much overlap. And then we'd be saying those 3 are in both sums, so this digit is the same as those digits, so that would become 4 and this would become a 6, and that looks like it might work. That would be a 4 in this row, so we'd be summing those 4 up. Okay, I don't think I can disprove that immediately. At least I couldn't see a way of doing it. Now, what about if this is a 4? If this is a 4, we lose a degree of yellowness. This still can't be a 9. Because we've got, yeah, so this is never the 9. Maybe that's a point we can use to our advantage. When this was 5... this couldn't be the 9 either, but if this is 4, can that be the 9? Yeah, maybe it can. And then this square would have to be the sum of those 2 squares, which means this square would have to be a 5, which would be very nice. It would give me my 6-8 pair in row 5. Oh, right, okay, that's complicated. Right, hang on, I think we need to explore this a bit more, because I've just noticed something else. Yeah, hang on a minute. I think we've got to be careful here. I think we've got to do this carefully, because I think we need to consider this domino a little bit as well, and what it can be. Because what I can't do is leave myself with a 5 and a 6 here, because that's going to break this domino. And when this is a 4, yeah, I do need to think about this, sorry. So, if this is 4, we know the x sum is summing these cells, and then I've got a choice of where the 9 goes. Now if I put the 9 here, I think this is a problem. Because if this is the 9, the sandwich is those 3 digits, and the x sum is the yellow digits. So these are overlapping, and we get left with a position where this square has to be the sum of those squares, which is fine in theory. It's a 5, and that's a 6, but now I've got a 5 and a 6 ruling out, making this a double 8. So that does not work. Now, what I can't tell, because I'm too stupid, is whether or not this 9 is just automatically broken as a result of that logic. I have a feeling it's got to be it's too small now, because now, in terms of the sandwich, we've got these purplified, those overlap, so they get unmatched, and these 2 have to add up. Yeah, it is right. Okay, my brain was sort of not letting me down awfully. These 2 squares now have to add up to 5. And they can't be 1, 4, and they can't be 2, 3, so it's utterly broken. And that is really massive, because now I think I've proved that this square is a 5, not a 4. And therefore this square is a 4 or a 6. We can re-yellowify row 5, column 1. We can now remove the 9 from here, unless my computation is going crazy, because, yeah, let's purplify just to check that. These will be purplified. They're the sandwich. And we have a situation where these 2 have to equal 0 in order for the instructions to work, and they don't. So this is not the 9. That's the 9. This is not a 9. There's a 9 over here now. And now we have a situation where the world is in order, because now the sandwich is those cells, they get purplified, remove the overlap. These have to add up to that, which makes this a 6, this a 4, this a 5-8 pair, which hopefully tells us what we need above that. The sandwich is 13, so I need these two to be a 2-6, don't I? 2, 6, 1 and 4 add up to 13. So we get rid of the 7 up here, and now I know that this is now a 3-7 pair, which I can fill in. I don't believe it. Wow. Which makes this a 4-6 pair, I think. 7 has to be here. I have a feeling that had to go with 4. I think I remembered there being a 4-7 pair here on one of our options, but I can't be sure about that now. Yeah, had to add to 11, that's why. Yeah, that's a 4, that's a 6. So that's not 4, that's not 6, that's not 5. This is not 4. Come on, come on, come on. We must be, I think we're doing quite well now. Come on, 7 and 8. Yeah, there's an 8. Well, it's got to be an 8 in column 1. 8 goes here, 7 goes here. 2, 6 here, so this is 5, 7. 8 here means that's an 8, that's a 7, that's a 7, that's a 5. So these two squares have got to be 2s, 3s and 6s, I think. I think I will pencil mark these as well. These have got to be 2, 4, 5 or 6. Seven. There are 4 7s looking at box 5. So that square is a 7. I've got a 1 here. So that is not 1. That is not 1. Okay. And now what? So is it this clue somehow that's going to tell me about the nature of the world? It might be. Okay, these are 2, 4 and 5. These are 3, 4 and 6. So I keep expecting there to be something. Oh, I lost my 6, 8 pair in row 5. That went away, look. So that's no good. That can't be... Oh, those two can't be 4s by Sudoku. Okay. Wow, this is a long video, isn't it? 1 hour, 18 minutes so far, and I'm still not finished. I hope you'll forgive me. I mean, I don't think this is the easiest rule set we've ever done on the channel. It's going to be a bit of a popcorn one today. Come on, though. I've got to finish it first before we can... Right, these squares, actually, I've just noticed they're a triple. So they are 2, 3 and 9, actually. Okay, 2, 3, 9. Nothing over here tells me what they should be. Right, so what we need to do clearly is to have a look at this row. So let's greyify those. Okay. So do we know anything about the 1s and the 9s in this row? We know that the 1 is relatively restricted, actually. The 1 can be in one of those two cells. So we also, actually that is interesting. So we also know that if this was the 1, where would we put the 9? It couldn't be next to it because that would break this cell. So I think the 9 has to go there. So that is one possibility. The 1 is here, the 9 is here. Okay. And that's a little interesting mathematically, isn't it? Because unless I'm missing something, which I probably am, but the sandwich there is those 4 cells. So in fact, let's just get rid of that blue for a moment and replace it there. So the sandwich is those 4, the x sum is those 4. Which means that we've got a 9 at the end of the row, and we know that the blue has to equal the grey. So 45 minus 9 is 36. Divide that by 2 is 18. These have to sum up to 18 each, which means those need to sum up to 13, which they cannot. Bingo. Bingo. Good grief. Okay, so now this is not the one in the row. It will not work. So the one has to be there, I want to say. I don't see how that logic is incorrect. So the 9, which can't be here. So the 9's got 2 places. Oh, but okay, we can try that. Let's try that trick again. Okay, so if that's the 9, I get the same effect. Look, let's get rid of the blues again. Let's bluify these. Now, it's exactly the same, except that we've got 1 at the end of the row instead. So that means that these have to add to 44 this time, which means they have to add to 22. Now those add to 13, so these have to add up to 9. And that doesn't work. That doesn't work either. This is so beautiful. So now that's not the 9. I don't see how it can be. So that's the 9. Which means those are not 9s. So has that, well, it must have helped somehow. I just need to figure out how. So now we are learning that. Let's do the bluifying trick again. So now it's these cells. So there's an overlap of this one. Right. So how does this work? We know that... why can't I get my head around this? It's because I'm getting tired now. So these add up. These digits individually add up to 44. But the grey ones plus the blue ones are going to add up to a little bit more than 44, aren't they? Because we're going to double count this cell. So, why can't I see what that means? That must mean so. I mean, obviously I can eliminate that. That is certainly a possibility, but I'm not sure how helpful that is. Actually, maybe it is. It's going to restrict this value. I can see how to do that. Yeah, okay. So now the possible values for grey are 18. That would be if this is a 5. And 21 if this is an 8. So, if this is 18, we know that's 18, that's 36. 37, this would be an 8, which doesn't seem to work. I hope that logic's right. It feels right. These, if those 4 and those 6, or those 5 add up to the same number, and I take out the overlap, it is true to say those and those. Yeah, I think that logic is good. So that seems to prove this is an 8 and this is a 5. Now let's just check this is going to have a value that's sensible. So now I've got 21 here, which means I've got 21 there. That's 42. 43 making this a 2. And that does look quite good actually, doesn't it? Because that seems to be giving me a 5 here. Now I can get rid of 2 and 5 from this square. So now we've only got left with 3s and 6s in the middle box. We can get rid of 2. That has to be a 2 by Sudoku. Has this done enough though? That's the other question I'm now worried about. Has this really done enough to disambiguate all of these extra things that we've got going on? I'm not sure. Really am not sure. Okay, come on. Let me think about this. Two, 3 here. 9 is in one of those. Oh, 1 now maybe we could have got that before. That's a 1 and that's a 9. So that's a 9 and that's a 3. That's a 3 and that's a 2 and that's a 2 and that's a 4. Aha. Aha. So that square, which is now not 2, 3 or 4, is 5 or 6, which means a 5 or 6 pair in the column. That gets me the 3 and the 6. Oh, I see, and that gets me the 5. And that's a 6 and an 8, which we can put in. Okay, I'm starting to believe. 4 and 8. Yes, 8 and 4. 5 gives me a 6 here. That gets me over here, 4 and 6. That's a 5. These are a 3, 4 pair not resolved. That digit's known. That's a 2. So that gets me a 2 and a 6 here. These cannot be 6 anymore. This hopefully disambiguates somehow. Yeah, we can take 2 out. So this is 4, 5 pair. Yes, 5 here. 4 here, 4 here, 3 here. That must be a 3, that must be a 6. Yes! Oh! Well, that is not a video that's ever going to go viral, which is so sad because that this exists is just... It's ridiculous. It is ridiculous. It is a clue. It's a puzzle defined by question marks, and yet it has a logical solution that is, well, it wasn't easy for me to find at least, but I have found it. That is absolutely remarkable. Emre Kalotoglu, take a bow. How you had the idea to make this and then did it like that, I have no clue. How is it possible to make this just from question marks? This is the sort of thing you could think about on a desert island, and, you know, ordinary minds would just never, ever get their heads around it. It is just incredible, the genius that we are subjected to day after day on Cracking the Cryptic. These constructors are off the charts clever. That is another example of absolute brilliance. I'm going to look forward to the comments. I'm going to be interested to see how many of you solved that one. And if you did... how easy you found it. I did not find that easy at all, but I would rate it 100%. So thanks for watching. We'll be back later with another edition of Cracking the Cryptic.